And they lit up, and they do have a function actually. That's where we left off last time. Yeah, a laboratory water bath with a heating unit, including temperature cutout, and yeah, two sensors, one measuring the temperature of the water bath itself and the other the temperature of the heating unit. Card link. And the question arose, what will go to the other end of the cable? And the answer is a temperature controller, of course. And inside the controller we find nothing yet. But there will be one board in the back with power electronics and all the intelligence. And there will be one board in the front for the front plate. And today I want to start with the front plate part. I won't bore you this time with a cut together and or time-lapse video segment about how I made the board for the front plate. I present to you the almost finished product, but not without interjecting a little rant about what I've gone through, because that here is a result of my third attempt. That here, this atrocity, was my second attempt, but it gets worse. That's my first attempt. And yeah, in that batch I tried at the same time to etch the controller board for the back, and yeah. So what happened was I changed my board material. Usually I buy Vanguard FR4 positive photoresist 1 ounce in Euro format, so 160 by 100 millimeter. But for these boards I bought some larger chunks, I think 150 by 300 millimeter, also Vanguard, also FR4, also 1 ounce, also positive photoresist. And I used the exactly same process, and that was the result. And my first idea was, okay, maybe my etching solution is used up and I need to make some new one. So I did, and yeah, I etched that board first in the old etching solution for hours, and then in the new etching solution again for a few hours, and that's the result. So my idea was, okay, maybe I need to expose these boards a little bit longer. So I went up with exposure time from 3 minutes 15 to 4 minutes, and that was my second attempt. Also after etching in fresh etching solution 4 hours. But what I noticed in the previous 2 attempts was that I had some little flakes of photoresist in my etching solution. And I never ever had that before. So in the third attempt I went up to 4 minutes 45 exposure time. And when I developed that board, I used a little brush at the end to go over the whole board and brush off any loose photoresist. And yeah, you see the result. Obviously that batch or these board formats, the photoresist leaves a little, even in the exposed areas, leaves a little bit on the surface of the copper. And that absolutely blunders the etching process. Okay, enough of that. Let's go to the front plate. So that's the board that will go behind the front plate and will contain all user interface elements, but for the mains power switch. And we already seen the board and the front plate, and the idea is that the board is in both axes completely centered on the front plate. And the reason I haven't finished that board is that I will use the holes in the board, or some of the holes, to locate the holes I need in the front plate. And that would be 4 screws at the edges, holding the board to the front plate. 2 holes for LEDs and 1 hole for rotary encoder. And I will show you the circuit and maybe talk a little bit about the layout of the board. But if you're really hardcore, I made 2 atrocious videos about how I created the schematics and the layout in DipTrace for that board. And don't watch it, but anyway, card link. So now let's center that thing here somehow and transfer some marks for the holes I need. I centered the board on the front plate to the best of my abilities using a caliper. This is just touching here, and that's 5.6 millimeters. And I did that on all 4 corners, and in the other dimension it's 14.75, and I won't adjust the caliper again for that. Anyway, I can now transfer the holes I need to my front plate. Hopefully. No, that's not working. I need a drill. And if I have to use an 0.8 millimeter drill to mark the holes, I can drill them right away with 0.8 millimeter. They are little pilot holes. Please note, the sole purpose of a few holes here on the PCB is to make markings on the front plate. For example, I have a little hole here between 2 pins of an LED, so that should be the center of the LED. And I have a little hole here, that's the center of a rotary encoder, where the 6 millimeter shaft should stick out through the front plate. Anyway, I can finish drilling now all the holes on my PCB to size, and I can make the first 7 holes on my front plate. And I've just done that. So the 7 holes, 4 for the screws, nicely countersunk, 2 for the LEDs, and 1 for the rotary encoder. And you see the holes in the PCB line nicely up with the holes in the front, and also the center hole here from the rotary encoder. And I also finished, don't lose the screws, drilling the PCB, and I also made a cutout here and fired a little bit off for a large holding tab from the rotary encoder. And I have to admit that I messed up at one point. That's the second try. That was my first try, and you probably see it, but the holes for the LEDs are 6 millimeters. And the hole for the rotary encoder is 7 millimeters, and I did the 7 millimeter hole by hand, and I got the wrong hole. Shit happens. Anyway, time to solder, and now I'm losing the screws, the PCB, and then I come back to you. I finished soldering the board, and there was not really much to it. Most of the components here are these headers where some stuff will go in, and of course a rotary encoder. But I want to point out a few details of the layout. Yeah, I already put a card in the link here where I made the schematics and the layout of the board. So there are some changes. For example, here, this area where you have rather large creeping distances, yeah, at least 6 millimeter, but I guess it's a little bit more to the rest of the board. This will be connected to AC mains, not directly through AC mains, but it will have a connection to AC mains. So this is an isolated area here. Also, these clamps which you are bent over to hold the rotary encoder in place. There's a little bit of isolation material here so that the clamps don't contact the copper of the board, so that the body here and probably the rotation axis and maybe a knob here stay isolated from whatever is going on the board. Nothing else. There will be a flat flex cable or something going in here at a later point, and also a cable here which is connected to mains AC. So yeah, therefore 2 different cables will go in here, but for now I leave them out because this would make things a little bit clunky, hard to handle. Anyway, there's a LED going here, just, indicating if there's power on the 5-volt rail, and there will be an LED here indicating if power is going to the heating element in the water bath. And these 4 connectors are for 1, 2, 3, 4 7-segment LED displays, and I did a video about those things too. In fact, 2. I don't know. Maybe I'm running out of cards. So maybe cards here, but links in the description. And these should go on like that. Yeah, there's not much spacing. And to give them a little bit of mechanical rigidity, there are these holes here. Okay, and there comes very little M1.6 millimeter screws into play. So let me attach the screws to the board and then we attach the displays. The screws are in. And please note, there is also no electrical connection to these screws. And there is, on each screw a second nut, which I hopefully can use to, right way around, to, adjust the height at one end of all the displays until they are all level. And that's basically what I will be doing now. And I come back to you when everything's assembled. With all the displays on, this is getting a quite heavy and massive affair here. And we can now pre-assemble the whole thing with the front plate, the right way around, of course. So that looks almost good. The only problem is, of course, I now need holes, but pre-assembled like this, I can now mark where I need to make the holes. Instead of relying on the measurements of these Chinese modules, I marking it as is, and then I will cut the holes. Wish me luck. I drilled a hole in each corner of each cutout, and I will now, fence each line off and saw it by hand. Quick update in between. We're not just there, almost, but I guess I have to use the file and the fence a little bit more. Come back to you as soon as I got it to fit. There is no special sauce to get that done. I mean, you set up the fence and either when it's in parallel with the caliper, you make sure it is parallel, or if it's at the right angle, you just align it as good as you can, and then you file off a few tenths of a millimeter, and then you check again if it fits, and repeat, repeat, repeat until it fits perfectly, or well, at least good enough. You could still do some work here, but it's fine. It's fine. And I still need another cutout here for the AC mains power switch. So let's do that now. Okay, that was only a little bit of filing after I drilled the 6 holes, and the dimensions are not so critical because it's a snap in, and this is kind of forgiving because it has a frame. And I was okay. Oh, got lucky there, huh? Okay, and now we can put everything together, I guess. Oh, forgot something. 2 LEDs. Just a sec. Okay, and I have these, there goes the LED, holders here, which are also snap in. And I have to watch the orientation here. So this is plus. So the LED goes in here, and plus is on the right side. Let's see if we get this right. Rotate it a little bit. Yep. That looks all right. Okay, 1 LED, and the other LED and now of course the leads are too long, so this will obviously go in here and in here, but I will have to shorten them while I screw everything together. But you don't have to watch that. Snipping off millimeter by millimeter until everything fits. So I'll see you when I've put everything together. Finally. It's done. Okay, the knob is missing, but I have to order that. Yeah, I even blackened the screws just for the looks of it, so everything on the front plate is black. And it's a dense affair because there's not much space in the case. Anyway, word of note, the isolation here on that screw, and I measured it. I made absolutely sure these screws have no connection whatsoever to these pins here and to that copper. If I had space, I would place the screws with a little bit more distance, but I hadn't. Okay, and I can't go into this area because this area is connected to mains AC. Anyway, let's put it into the case and have a look-see. And yeah, slid into the case. You see, there was not much space I could work with. Yeah, I used every millimeter available to me, but I didn't want a bigger case because that would have been wasteful. And yeah, it's okay. Yeah, there are some, yeah, here the cutouts. It could have been nicer, but anyway, it looks acceptable. Anyway, let's try and light that thing up. But before I can light it up, I had to solder on a connector. And yeah, to dimension the length of the cables, I used the botched up controller board. Yeah, my first batch of mishapped etchings. And I made a real printed circuit board out of it, so I know where my connectors go and how long the cables have to be. Okay, now let's write some software for the Arduino and light these up. And they lit up, and they do have a function actually. I mean, the rotary encoder is obviously setting that display here. I mean, it's not perfect. I just hacked together some code. And these are actually displaying temperatures, and I have temperature sensors here at the back. And you can see temperature is rising, as is my confidence. And I take that basically all that data from the temperature sensors I had on the breadboard from one of my last videos. Card. No, probably not card. I'm out of cards. But links. Anyway, I will spare you the code because it's well past 9 p.m. and it's atrocious. And we will have in a future installment in the series enough opportunity to go over the code again. To get here, it was not without a little, quite a big hiccup. The first time I turned it on, all displays stayed black, absolutely black. And after some debugging, first in software and then, before checking your voltages, check your connections, I noticed that the crimp connection of the data line to the displays was dead as a dodo. And that was not the first time I had a problem with crimp connections. It was the first crimp connections, and I noticed I used the wrong crimp size for it. 1.4 instead 1.6 for the wire itself, and 1.6 instead 1.9 for the strain relief, but it looked. I had to bend it a little bit back and forth, but it looked good. But obviously, didn't work. Yeah, not the first time I messed up a crimp connection. So test your crimp connections before you use them. That was a while ago. As I said, probably no card, but a link below. It was on my UV exposure unit. There I fiddled around with a dead crimp connection or switched crimp connections for quite a while. Anyway, past 9, time to go down and well, maybe watch some TV or whatever. Anyway, that's it for today. I'm happy, and with that I say bye.